We're continuing with internal microprocessor structure. In examining the internal structure of a microprocessor, the elements that are needed to drive the address bus are. And so what we're looking at this point is the address bus. And so in the grand scheme of things, here we had the microprocessor memory and the three buses, and we're looking at the address bus. And what is needed to drive the address bus? Well, first of all, we need a program counter. It is the origin of the memory address for the stored instructions. The number of stages are dependent upon the number of address lines. So in this case, if we had the 1K of memory that we had previously discussed, then this counter would have to be able to count up to 1024 to adequately address all of the addresses that are in this particular memory. The number of stages, as the counter counts, it is retrieving or writing instructions from or to memory. So as this counter counts up, it is retrieving memory or retrieving instructions from memory. Now it is either retrieving them or it could be writing them to memory in the case of the microprocessor writing data to memory and an output. Additionally, the program counter tracks the execution of a program when branches are executed and it is necessary to return to a particular location in the program. So as these commands or these instructions are executed by the processor, the instructions may direct the counter to go to a specific branch or to a specific number in the counter. The counter can be redirected to a count that is not sequential. Okay, the general process is output and address. Okay, it starts with an address on the address bus, and this is a function of the counter. Read the instructions stored there. So the microprocessor reads that instruction, then it executes the instruction. Then increment the counter to the next address. And so the counter, in a methodical way, retrieves addresses and feeds them to the processor for instruction. Okay, internal microprocessor structure. Program counter can be preset. To begin a program at the proper point, an initial starting address is required. Initial values are preset and usually activated by pressing a reset pin on the microprocessor. This is kind of like if you have a PC and you press the reset button or the start button, the computer starts up. But you might notice that it doesn't start up on the operating system. It starts by executing the information in ROM. It's called the BIOS. And so it starts that there's an initial startup program, and then the BIOS calls the operating system. The actual address is determined by the microprocessor manufacturer. So when you press this preset button, it goes to a specific address, and that will be determined by the manufacturer of the microprocessor. For our discussion purpose, the preset address will be, we're just going to go to 00000, the very beginning of memory. In fact, we might say 00001. Okay. The data bus drivers. The data bus requires a device capable of both read and write, transmit and receive, or in and out operation. Data bus lines are bidirectional. A bidirectional bus driver, or more correctly, a TriState bidirectional bus driver, is used to accomplish these functions. Now, this has to do with the data bus, okay? So let me jump back just a couple slides here. And we're talking about this right here at this point, the data bus. You'll notice that the address bus, it's a one-way, control bus, it's one-way, processor to memory, but data has to be able to flow in both directions. And so that's why we need some kind of device that will allow us to have this bidirectional control. And so we have something called a data bus driver, and specifically we're going to use a TriState bidirectional bus driver. TriState meaning that it has 3 different states, and the 3 different states would be that you're moving data from memory to the processor, from the processor to memory, and then the third state is that it's not doing anything. And so first of all, we have 2 inputs going into this TriState driver. We have the designation we show this is in or out, and what this simply means is data being sent into the processor, or is it going out of the processor. And those 2 states will be determined by either a high or a low. Notice here the out not, that would be a low, so you would be moving data from processor to memory, and if it's a high, you'd be moving data from memory to the processor. Now then we have the bus enable right here. If it's low, notice the low comes in here, it's going to, both of these AND gates will be disabled, and that will create a high impedance state, and that's where data isn't going anywhere. We're just stopped. The high allows data to move depending on the state of the in or out not. So if you have a high here, it'll enable either input or output, but that will depend upon what we have on this input here. So this function is controlled automatically by the computer. You don't need to go in and try to adjust this. This is just an automatic function. Now what we have here is the schematic from your MultiSim package. This is figure 16-2 MSM. This simulation shows the bus enabled and inputs selected, causing data to move on the bus driver to the microprocessor. So here we have, this side would represent the microprocessor, over here would be memory, and what you'll note here is these little LEDs are illuminated, and what that is indicating is that data is moving from memory to the microprocessor. So this would indicate here we have a high coming here, so this AND gate is enabled, allowing data to move in this direction, and the bus here is enabled. We have a high here going, so this gate is enabled, so we have data moving as an input. If this would have been in this position down here, then we would have been moving data in the opposite direction, and these LEDs over here would be illuminated. If this was in the low position right here, the bus would be disabled. This would be the third state, and there would be no data moving anywhere. Okay, so this has, we've looked at briefly at the subject of TriState drivers. And okay, that concludes this particular lesson.